To better understand OPC, let's have a look at a specific example. In this case, a large petrochemical plant wanted to monitor their turbines using three applications: a human-machine interface, or HMI for visualization, a process historian for data storage, and a machine condition monitoring application. The data came from three different data sources: a PLC, a vibration monitoring system, and a calculation engine. Heading into the project, the plant had three common requirements. One, they needed to minimize the number of data requests because the controllers could not provide data very quickly. Two, they needed a system that was relatively quick and easy to implement. And three, they needed to pay as little as possible for the entire communication infrastructure and its implementation effort. The first option was to use the proprietary connectivity method. Each application would communicate with each data source using its own interface or driver. The HMI needed three drivers to communicate with each of the data sources: one to communicate with the PLC using the TSAA protocol, a second to retrieve data from the vibration monitoring system using Modbus, and a third to receive pre-configured calculations from the calculation engine using DDE. The process historian also needed three drivers, as did the machine condition monitor. In total, 9 custom drivers were required. In this case, you will notice that each data source would have had to provide the same data 3 times, once for each application and its associated driver. This would have created a tremendous load on each data source due to an excessive number of data requests. It was estimated that it would take approximately 10 days to complete the installation and commissioning of the drivers at a cost of over $50,000 for the software and the associated labor. Now let's take a look at the OPC solution using the same data sources and software applications. Here, we used one OPC server for the PLC, one for the vibration monitoring system, and one for the calculation engine. Since the HMI, process historian, and the machine condition monitor already supported OPC, we only needed 3 interfaces, which was 1/3 of the proprietary method. Because OPC is a popular communication standard, the interfaces were available off the shelf, so no custom software development was needed. Notice that there is only one connection between each OPC server and its corresponding data source. When an OPC server received 3 data read requests for the same point, it only had to send a single request to its data source. This drastically reduced the data request loads on each data source to 1/3 of the proprietary method, and significantly increased the performance for a slow serial protocol such as Modbus. The OPC solution only took 2 days to install and commissioned at a cost of less than $10,000 for the software and associated services. The OPC solution helped the plant meet all of their requirements. It reduced data request loads on each device, minimized implementation time, and reduced their software acquisition costs. All of this was achieved with commercial, off-the-shelf software.